6.01, solving for x-intercepts, model A. So this first model is just like what we did in Unit 5, so this should be review. We have a trinomial. It says solve for the x-intercepts of the following equation. So we're going to set this to equal 0 and solve for x. The easiest way to do this is to factor it if we can. So we do box method for the factoring. 4x squared goes here. Negative 10 goes here. Because our a value is not 1, then we want to go into our little cross method. So a times c and b. A is 4, c is negative 10. So that means a times c is negative 40. And our b value is just 3. So a factor tree of negative 40. See which of these adds up to 3. 3 does not go into it. 4 does. 5 goes into it 8 times. 6 does not go into 40. Now that it is 7. So we've counted around to all of our factors. Now since we're looking for a negative number, we know one of these will be negative. So negative 5, positive 8 gives us 3. So negative 5x, positive 8x. Now let's factor going up. Oops. Going up. So you can pull out a 4x. Erase my arrow. 4x times x, x times negative 5, negative 5 times positive 2. So we have 4x minus 5 times x plus 2. Ran out of space, so I'll do that up here. So our x for that, we set to equal 0. 4x minus 5 equals 0 means that our x will equal positive 5 fourths and negative 2. So 2 answers. Remember, that should be review, so hopefully it's not too hard to do that problem. Okay, model B, we have our equation in vertex form. So first thing we want to do is get this to be standard form. I'm going to work on part of this over here. So we have x plus 1 squared. So to evaluate that, x plus 1, x plus 1, x times x is x squared, x times 1 is 1x or x. Same thing down here, and 1 times 1 is 1. We have like terms, x and x, which will be 2x, so we get x squared plus 2x plus 1. Now don't forget this 3 out front, so that's still there, and we have a minus 12 at the end. So when we do 3 times x squared, we get 3x squared. 3 times 2x is 6x, and 3 times 1 is 3, minus that 12 at the back side. That should be a plus 3. 3x squared plus 6x plus 3 minus 12, that turns into negative 9. So 3x squared plus 6x minus 9 is our new standard form equation. We are now going to try and factor that to get our x-intercepts. 3, 6, and 9, we can factor out a 3 out of all those. So 3 times x squared plus 2x minus 3. Now we can factor this. This one's not super hard to factor. We get x squared in the beginning. We get a minus 3 in the backside. What multiplies to negative 3 and adds to 2? 3x and negative x. Factoring going up, we pull an x out. X times x times 3, and x times negative 1. So we get x plus 3 times x minus 1. Therefore, our x values are negative 3 and positive 1. So x equals negative 3 and positive 1. All right, one more equation. Solve for the x-intercepts of the following equation. So same thing. Let's multiply this out. So we get x minus 5, x minus 5, x squared minus 5x minus 5x, and positive 25. Like terms are in here. So when we add those up, we're going to get x squared minus 10x plus 25. And we still have a negative sign out front with a positive 48 on the back side. Okay. That negative sign out front just changes our signs. Negative x squared, positive 10x, minus 25, and positive 48. Let's evaluate our backside here. Negative 25 plus 48 gives us positive 23. So now our new equation is negative x squared plus 10x plus 23. Okay, so we have this. We could factor out this negative sign. So we get x squared minus 10x minus 23. Now, the problem here is we cannot easily factor this, okay? So we're going to solve it in a different method. So quite honestly, everything we did is actually all for naught. I just want to show you why we're changing our method. Because sometimes we can't factor our equation. So we're going to start here, and we're going to set this to equal 0, and we're going to solve for x. So I'll rewrite the equation. 0 equals negative x minus 5 squared plus 48. So the first thing we want to do is work away from our x and shrink to our x, or get closer to our x. So we're going to subtract 48 from both sides. So we get negative 48 equals negative x minus 5 squared. We have a negative sign out front, which is really a negative 1. So we're going to divide by that negative 1. That changes my 48 to a positive 48. Now we have x minus 5 squared. So square root both sides. So we're going to cancel out the square root and the square. And our left side becomes plus and minus square root 48. So we're left with plus minus square root 48 is equal to x minus 5. The last step here is we want to add 5 to both sides. Add 5, add 5. And you want to have your single number in front. Plus minus square root 48 equals x. Now, if you have to graph this, you're going to want to approximate this answer. Square root of 48 is approximately 6.9. So we have 5 plus 6.9, which would equal 11.9. And then 5 minus 6.9, which would give us negative 1.9. So those are our two answers, and you can see they're decimals, which is why we were not able to easily factor it earlier.